Thank you for coming. And I will not be talking much, but I will be showing a lot. Being the last one, you might already have had a lot of input. It's great to be in Cyprus. It's my first time. Thank you for having me. Thank you for the hospitality. I'm already leaving tomorrow. I am showing one piece in this exhibition, which is now switched off. I will show it on the screen. An artwork I made in 2021. I will show some other older art pieces that I made that led up to that piece. And we'll demonstrate how they work. I'm an artist from Amsterdam. I live in Berlin for 13 years. I studied software engineering and AI at the university in Amsterdam, and then I went to art school. So I'm a bit in both worlds. I never really saw much of a problem or a distinction between technology, software engineering, AI, and an aesthetic, artistic practice. I am going to show a little video. It's about 4 or 5 minutes long, and I hope the audio comes across, but I will also give a short summary. It's by a very smart guy, Vinay Gupta, and he is talking about how dating apps, platforms like Tinder or Hinge or other, how these platforms try to make matches between people. They try to find partners for people, but also they run a business. So if the app works really well and people find their soulmate and they stay together, then they will not go back to the app. And that's not a very profitable business model. So Vinay Gupta proposes that these bigger systems being operated by AI, they might optimize themselves through training data, through learning, where they would try to make matches, but at the same time also generate the most revenue, so that the matches that will be made will be of the nature of short-lived, maybe sexy, explosive relationships that don't last. Because then people will, and so then they'll go back to the app. But then on these short-lived, I will just show you the video.
So, right. So, I want to take this as an example of a part of life which has been heavily transformed by data and the access to data in ways that really nobody is entirely comfortable with. And, I've roughed this number at 10%. I've read various numbers from 7 up to 15. And, you picture social data, but nobody can deny that internet dating has become a huge part of how we meet each other, and meeting each other still turns out to be a critical part of compatibility. So we're in this kind of crossing point where the data thing is beginning to really substantially impact people's personal lives in ways that everybody is a little shy to discuss, but actually it's becoming quite pervasive. And what you'll think about if we were having this talk, around the time that our good friend Norbert was gave his talk. Imagine what he would have said if he'd known that in the future, 10% of human beings would be created by matches that were made by a computer. Right? Can you imagine the anxiety that would provide our forebears? Right? Our forebears would have been astonishingly nervous. Oh my God, how will the machines choose who should be the food? Over a few generations, will that steer the entire human race in completely different directions? Right? But how will we make the machines decide how to match people? Now, remember I was talking before about mechanisms, right? So an internet dating service is a mechanism which has many effects. One of them is making you equals, according to a set of matching criteria that are embodied inside what amounts to an economic engine, an economic gain. So the humans that are matched by an internet dating are the humans that it is most profitable for the internet data set to match. Does that seem like a reasonable set of criteria for making 10% of humans?
I will leave it to that, the fragment. So on these dates that are matched, that are created by this algorithm, these people might have sex, even though they might not also not stay together, but children might be born, and that match made by the algorithm has a genetic component. The DNA of the children is partially configured by a dating algorithm. Well, I found that very fascinating, and I applied this thinking about creating artworks, visual artworks, in a similar way where I thought, could I consider a population of artworks that mate, they procreate, they have a family tree, some artworks have children, all artworks have parents, and breed and crossbreed and select different art pieces and have them breed and see what the children would be. So this was my first attempt at using genetics in the creation of artworks. The whole population is, I think, about 80,000 specimens. And at this time, Facebook was relatively new, so I thought maybe I could make this a social network. So the artworks are all part of a family tree. These were born 7 years ago, it has been seen this many times and it's still alive. And these are the parents. So if I look at this one, you can see this one is kind of gray, and the parents are also kind of gray. If I look at this one, these parents, so you can see this line here, which is also appearing here, and also a similar kind of line here. And so the children inherit certain traits of their parents. So if I look at one specimen, these were the parents, but this one does not have siblings. Let's search for one with siblings. Yeah, so it has one sibling, and these are the names of all the artworks. And in this case, I was the breeder. I decided which artworks I wanted to combine manually. I built some kind of simple app on my phone. If I would be waiting for the subway, that I would just be breeding, which is really fun. And I would also decide who would get to live and who would get to procreate. So it was a very dictatorial kind of regime in this population where I was playing God. And at some point, the works that I found personally the most compelling, those works were then sort of exported from this system in different layers. I would call this process freezing because they could not procreate anymore. And I would then send that to a manufacturing process. Where they would be turned into two-dimensional objects. And it was my idea that those frozen artworks could be sold, and the money made from that could be put into the server hosting of the whole population, and eventually the system would learn my preferences and would be able to do it by itself. So also when I would be dead, that the specimens still continue. That was kind of naive, because I noticed that for a neural network to understand my preferences, I would need to train it. But if I'm just the only person training it, I would need to train it for maybe a few hundred years before it gets what I like. But still, I like the in-between outcomes. I also created, to show the breeding process, a piece of software. Let's see if it runs here, which also, I'm running off my phone, yeah. So it's selecting one specimen from the population at random, then it's looking for a partner. This is made for museum display, so it's kind of slow. Things in museums are slow. So this partner is selected. Now they're breeding, they're having sex. So these are some of the children. You can see some similarities, they're also in ways different. And then the ones that are not fit enough, they are killed, they will disappear. In this case, they can, those ones disappear, not fit, so those can stay. And then from these children, one is selected to then continue breeding with a new, also with a partner. you can see they always have three parts of the name. The first one, Vanessa, is the name of this specimen, and the other names are the names of the two parents. So with every name, you can trace back the whole genealogy of all the artworks. And this goes on forever. I had some ethical obligations about this artwork, because I didn't like that I had to manually train the artwork to train it what I like, because I thought, why is it so interesting what I like? Why me? And so I created a new similar work, but also quite different, where it was not me making the selection of who gets to procreate, but every internet visitor would get to make this decision. So it shows on this website 8 specimens, and this is also online. Everybody can play with this. So you could, let's say I like this purple here and this purple here. So those two breed, and these are the 8 children. So they're still quite different. So let's say I take this one and this one, and you can see that gradually they will start to become more similar, because this is incest. These are only brothers and sisters having offspring, so this is a loss of diversity in the population. So eventually it will converge to one specimen. You can see they're very similar. So this one, these three ones have a particular gene set to green, where these ones have it to white or light green. And this process of selecting from a specimen to either eliminate traits or emphasize traits is called hybrid vigor. And we know this from dogs. Dogs are bred like this. If you want an aggressive dog, you have 5 little dogs, you look which one is the most aggressive one, you take that one, and you breed that with another very aggressive dog, and then and we do this with flowers. This is how already a very long time ago roses or tulips have been, before we had genetic modification, we did it by hand. And all the visitors of this website, which is a lot, I don't know, maybe 100,000 people, each time when they complete their breeding process and when they become very similar, so I have to do it 2 more passes, I think, or 3, then it says, okay, there is no point breeding any further because all the brothers and sisters are basically identical. And then it stores this conclusion in the database, and then it uses that as output for other people. So it's a kind of a crowdsource breeding process looking for the optimal drawing, which is all very problematic, I think. Most of the times when I have algorithmic works, that at some point there's an output, there's a sort of temporary conclusion, and then I have these works also frozen into material objects. So I'm showing you this. These are kind of the conclusions of this algorithm, which are then also shown in, well, there's also some other works, which are shown in exhibitions. So that's kind of the whole cycle of the algorithm towards the exhibition. So these 2 works, Death Imitates Language and Hybrid Vigor, were the predecessors of the work that I have exhibit in this exhibition. What I liked about these 2 projects was that the outcome was to a certain extent not predictable, but I could still steer it into the direction that I wanted. So I was kind of half in control, half surprised. I was half the artist, but also half the spectator. The problem I found was that the output at some point became a bit monotonous, they all became a bit too much the same. So I thought, how can I make a new algorithm where the outputs, all the specimens in the population, are very different from each other? And I found an algorithm called Cartesian genetic programming, whereby the chromosome of the artwork, because each one of the specimen, they have their chromosome, whereby the chromosome is not just data, but the chromosome is like a computer program. And this is not my invention, this is how our body works. If you take, for example, your lungs, they have this kind of, they look a bit like broccoli, you know, and they start with big, yeah, thick parts, and gradually they make smaller parts till they get to the final terminator nodes. There is no part in your DNA that describes every branch in your lungs. What your DNA contains are instructions for proteins that are repeated and repeated with rules and conditions. And one of these rules is if the branching becomes like less than so many cells, stop branching and absorb energy or absorb oxygen. So the DNA itself is full of little computer programs itself, because if the DNA would need to contain all the information about, let's say, your fingerprint or your lungs or about hair, which I don't have, then that would never fit in the chromosome. The chromosome would be way too large. And I like this idea that encoding complex structures like a human body, that this information is basically compressed into the DNA. It's a bit like a zip file. The enormous amount of information that is the body is compressed in rules to make it work. I found an algorithm that already existed called Cartesian genetic programming that works a little bit like this. And the technology is a little bit, or the algorithm is a bit complicated for, I'm just showing this image. I barely understand this image, but you can represent a computer program instead of numbers. You can represent it as a tree structure or a graph, whereby each, in this case, circle is an instruction, and it can jump to another node. And the genetic component about it is that you can mutate computer programs. You can create variations of computer programs that will be a different program with a different output. I will not go into the halting problem, but let's see, what shall I show now? Yes, this one. Oh, I meant this one. So this is basically an interactive version of the artwork that is in this exhibition, Mutant Garden. So we see again 8 specimens here. And you can see they're quite similar, but also they're all a bit different. And I believe this has a lot to do with aesthetics. Our appreciation of aesthetics, our understanding of music or images, is a lot to do with recognizing similarities and recognizing when things are not similar, when there's a change, when there is something, an aberration, a variation. So change and variation are kind of, I think, key in music. And I like this to be a variation machine. So let's say, which one shall we take? I like the colors in this one. So unlike the previous 2 algorithms, where there would be 2 parents, and they would have children, Cartesian genetic programming does only require 1 parent. So I think in nature the snail can procreate, snails, you know, hermaphrodite animals. Anyway. So I'll pick this one, and now the other ones are replaced with variations of the one that I just selected. So let's say I take this one. And this is interesting, this mutation that caused the color to be way more purple. So if I select this one, I expect the other ones to also be more purple. So this is also a way hybrid vigor. I select the variation that I like the most and then continue on that one, except that there's only 1 parent necessary. But this one has quite bright colors, so those will have that too. And then if I at some point like one, let's say I like the colors in this one, I can send it to the garden. And this is my collection of specimens that I want to keep. And of course, I'm also recording this from all the other people who are doing this, so I can find out what are people their aesthetic preferences, which is kind of a little bit like an anthropological research. The non-interactive version of that art piece is, like I said, in this exhibition. I'm showing an image here of the same work, but here it's installed on 3 vertical screens next to each other. So this is quite a bit bigger. So again, to come back to this more technical, unclear part, how does the algorithm work? Because this is important for me. I do not want to be an artist who is like a magician, showing complicated things and then pretending it's magic. I want to kind of explain how things work. I want to demystify algorithms. So I created the Mutant Garden tracer, where on the right, you can see every dot is a computer instruction and every line is a jump to this. So the network I just showed, this black and white diagram, is basically this, except that it's way more complicated. And you can see that it starts on the top and it branches out to the bottom, and occasionally it can jump back and go back again and go back. And so these are loops. Similar that in your lungs, there's a loop that decides if it still should branch off or if it's the end. And you can see that the instructions here create this image. So instructions could be, for example, draw a circle or draw a square or change the color from red to a little bit more purple. So this is the palette. This work only has this many colors at that moment. And similar to the other two collections or the two series that I showed, once the software reaches a point where I find the outputs interesting enough, then I call it manufacture, which is a bit an ugly word, but I turn them into these material objects. This was an exhibition in Amsterdam at Upstream Gallery. And for me, it is very important to also show these works as objects, because in the end, what I'm interested in is making images. And I'm very interested in the history of making images. And I want the images to have a scale, I want them to have a size, and I want them eventually also to be hung next to an oil painting. Because I want to see if my image, if it resonates with something else, something older, or another material. So the making of the object is for me kind of the way to release the work in the wild. And also, once it's fixed, it cannot change anymore. That's the last thing I want to talk about. The digital art is always changing, right? It's on your computer or on a network or somewhere, and it's in the nature of digital files and computer programs that they change. You can always change them. You might even not see that they have changed. When Trump went to office the first time, he removed all mentions of climate change from the White House website. And then they were just gone. We didn't know. And I thought, is it possible to be a digital artist and make digital artifacts that cannot change? Like a marble sculpture, it cannot really easily change. And then I encountered blockchain, which is almost a swear word. I'm very fascinated by blockchain. And I combined this Cartesian genetic programming algorithm to an Ethereum NFT. And these lived in the wild, they still live in the wild, and they sometimes change owner. And you can see here, in time, this is what it looked like when it was born. And gradually, over time, you can follow all the mutations of this artwork till the current state. It mutates only 3 times per month. And this becomes kind of a family album of the development of this work. And all the properties of this artwork, the colors, the palette, the name, these are all stored on the blockchain, and these mutations are also synchronized to the blockchain. So even if I die, or my server stops working, or whatever happens, the artwork cannot be destroyed. It will live on as long as the Ethereum blockchain lives on, and it's pretty likely that that will live on because there's billions of invested in that. And so this work, I do not have control over it. I cannot remove it. I cannot change it. And what I found very interesting is that some of the artworks that were developing in a particular way on secondary markets, they became more wanted by collectors. And some collectors might have bought a very lush, complicated, beautiful specimen, but then over time it mutated into this kind of boring gray square, and that meant that their investment was also lost, because NFTs are very much also currency. So this came a lot of speculation online in communities where people were trying to figure out what was the course of the mutant, what was it going to look like. And the whole point of NFTs was that we're not going to change and that they were a safe investment. But I made an NFT that kind of lives on, and it's unpredictable if your investment is worth its money. So it's kind of ruined the whole purpose of NFTs. Thank you.